Actually, we don't know.
Imagine that our compasses point south someday. This is not science fiction. It actually happened on Earth some 780,000 years ago, with a total reversal of the magnetic poles. Could we now be facing the same cataclysmic process again? No one knows. But we are witnessing Earth's magnetic field decaying by 10% or more in 150 years. And this process seems to have accelerated recently.
Stay cool. Hit the button, baby. This is a Thor News presentation. Thor News presents Party Dance Time.
I'm just catching up to speed, so bear with me. Hey y'all, I'm sure you've heard, but there's a jet stream in our core. I did yoga once or twice, and I found out there my core was a marshmallow. I need to toughen that marshmallow up. Alright, back to the serious science. We're over at ESA SWARM. What? Okay, talking about there's a jet stream in our core, buddy, which is weird. It means the carbon has gotten so bad it is now seeped into the core and is changing the climate in our Earth's inner sphere. Alright, December 19th. That was my birthday. Well, technically, it's still my birthday. We would normally associate jet streams with the weather, but thanks to ESA's magnetic field mission, scientists have discovered a jet stream deep below Earth's surface, and it's speeding up. Launched in 2013, the trio of SWARM satellites are measuring and untangling the different magnetic fields that stem from Earth's core: mantle, crust, oceans, ionosphere, and magnetosphere. Together, these signals form the magnetic field that protects us from cosmic radiation and charged particles that stream towards Earth in solar winds. Wow. 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 Measuring the magnetic field is one of the few ways we can look deep inside our planet. As Chris Finlay from Technical University of Denmark noted, we know more about the sun than Earth's core, because the sun is not hidden from us by 3,000 kilometers of rock. Asterisk, I'm not sure we know that much about the sun, man. Just because scientists are like, yeah, we know a crap ton about the sun. That don't mean it's true. The sun's the most powerful thing tangible in our solar system. Is your car powered on the sun, buddy? Is your house powered on the sun? So if scientists have figured out the sun, how come we can't harness all of its power and energy? The field exists because of an ocean of superheated swirling liquid iron that makes up the outer core, like a spinning conductor in a bicycle dynamo. What? Man, is there some guy conducting a symphony inside of a bicycle dynamo? What is that? What is that even? This moving iron creates electrical currents, which in turn generate our continuously changing magnetic field. Yeah, that thing is changing at rapid, scary levels, but whatever. Tracking changes in the magnetic field can, therefore, tell researchers how the iron in the core moves. I like the way you move. Dun-dun-dun. Hey, it looks like there's a little planet inside Earth. Maybe it's like a little sun. Maybe Earth-like planets turn into suns. You don't know. The accurate measurements by the unique constellation of SWARM satellites allow the different sources of magnetism to be separated, making the contribution from the core much clearer. A paper published today in Nature Geoscience describes how SWARM's measurements have led to the discovery of a jet stream in the core. Phil Livermore from the University of Leeds in the UK and lead author of the paper said, "Thanks to the mission, we have gained new insights into the dynamics of Earth's core, and it's the first time the jet stream has been seen, and not only that, we also understand why it's there." Well, good for you, buddy. Throw yourself a parade. One feature is a pattern of flux patches in the North Hemisphere, mostly under Alaska and Siberia. Flux patches, those are probably those lobe thingies I'm talking about. You know, lava lamp. I was talking about in my other videos. How the North Pole is just turned into a bunch of lava blobs. These high-latitude flux patches are like bright spots in the magnetic field, and they make it easy to see the changes in the field, explained Dr. Livermore. Man, liver's gross. Just throwing that out there. It's my own personal opinion. I'm not liver shaming you liver eaters. That's gross. SWARM reveals that these changes are actually a jet stream moving at more than 40 kilometers a year. Whoa. 3 times faster than the typical outer core speeds, and hundreds of thousands of times faster than Earth's tectonic plate move, and hundreds of thousands of times faster than Earth's tectonic plate move. Whatever. I can't think. We can explain it as acceleration in a band of core fluid circling the pole, like the jet stream in the atmosphere, said Dr. Livermore. Man, why does that accent just fall off? You faker? Oh, wait, I'm talking to me. So what is causing the jet stream, and why is it speeding up so quickly? I don't know. Maybe it's because the sun's pregnant? I don't know. The jet flows along a boundary between 2 different regions in the core. When material in the liquid core moves towards this boundary from both sides, converging liquid is squeezed out sideways, forming the jet. I want to access the video. Of course, you need a force to move the fluid towards the boundary, says Professor Rainier. Holler back, man. Yeah, holler back. He's also from Leeds. This could be provided by buoyancy, or perhaps more likely from changes in the magnetic field within the core. As for what happens next, the SWARM team is watching and waiting and pontificating and renumerating and flagellating. We all flagellate, man. Rune Flauberguggen. Sorry, Rune. I don't want to ruin your last name's pronunciation. Rune Flauberguggen, ESA SWARM mission manager, added, Further surprises are likely. The magnetic field is forever changing, and this could even make the jet stream switch direction. This could even make the jet stream switch direction. This could even make the jet stream switch direction. Unrelated side note, sometimes I repeat the most important information multiple times. This could also make the jet stream switch direction. This feature is one of the first deep Earth discoveries made possible by SWARM with the unprecedented resolution. Now possible. It's a very exciting time. Hey, say that again. We simply don't know what we'll discover next about our planet. Yeah. All right, so interplanetary climate changing. That's crazy. All right, so things are getting wilder, weirder, and wackier. Good to know. Leave all wonderful comments and observations in the comment section of the video. Now, peace out. God bless you.
There's really something happening with this Earth's magnetic field, which needs to be observed.
Now, we are looking at two different images here. The first is a snapshot of what our magnetic field looks like today, according to SWARM data. The second image we're going to look at shows changes in the magnetic field between January and June over a 6-month period. The areas that are pink and red show where the magnetic field has been strengthening, while the areas that are blue show where the magnetic field has been weakening.
The magnetic field has changed. We have expected that, but in general we have a weakening of the field, but a little surprised that there are some regions southeast of Africa where we have a strong intensification of the field.
But overall, the field is weakening. Now, in the areas that are weakening, in fact, if we look at the change map, we can see that the areas above North and South America are dark blue. They appear to be weakening the fastest, at least over this 6-month period. Is this concerning? Is this dangerous?
Well, the Earth's magnetic field acts as a shield. It protects us from charged particles from the sun. In the South Atlantic, and especially in South America, the field is weak.
Now, the data from SWARM also confirmed that magnetic north is moving, and it's going towards Siberia. What pulls magnetic north in that direction or any direction?
Actually, we don't know. Surprisingly, there's nothing similar in the southern hemisphere. So the south magnetic pole doesn't move that fast. We don't know why the magnetic north pole moves. We just can observe it, but the processes that are responsible for that are inside of the Earth at a depth of 3,000 kilometers, where we have molten iron moving around. They produce some electric currents. These electric currents produce a magnetic field, and that's what we observe. And depending on which of these features on the core surface is stronger or weaker, that has impact on how the magnetic field moves.
What pulls magnetic north in that direction or any direction?
Actually, we don't know.
Imagine that our compasses point south someday. This is not science fiction. It actually happened on Earth some 780,000 years ago, with a total reversal of the magnetic poles. Could we now be facing the same cataclysmic process again? No one knows. But we are witnessing Earth's magnetic field decaying by 10% or more in 150 years. And this process seems to have accelerated recently.
Stay cool. Hit the button, baby. This is a Thor News presentation. Thor News presents Party Game Time.
I'm just catching up to speed, so bear with me. Hey y'all, I'm sure you've heard, but there's a jet stream in our core. I did yoga once or twice, and I found out there my core was a marshmallow. I need to toughen that marshmallow up. All right, back to the serious science. We're over at ESA SWARM. What? Okay, talking about there's a jet stream in our core, buddy, which is weird. That means the carbon has gotten so bad it has now seeped into the core and is changing